Welcome to the reference video, or deep dive video as I called it. First and foremost, I want to stress that you don't need to use this scene in your game. The asset itself is just a single class that can be accessed via code. It has all the source code included and is well commented. This scene is just a more visual way of showing you all its tricks. Next up, this is a reference video, so it's probably kind of boring to watch from start to finish. It's something you can bookmark and come back to if you need to look something up. I'm going through every single feature this asset has to offer, and that will take quite a while. All right, let's get started with the data types. I already showed the byte in the first video. A byte is a number that goes from 0 to 255. Imagine you want to write a small number, but it can be negative. You can always opt for a signed byte, which goes from -128 to 127. If you need bigger numbers, you need more space. So that's what the short and unsigned short is for. The integer and unsigned integer, and the long and unsigned long. When you're using unsigned variants, they cannot be negative, and when you're using the regular ones, they can be negative. But of course, not as big on the other side, on the positive side. They always use twice the amount of space, so be careful. Always try to use the smallest one you can, because space is scarce if you're trying to hide things in a texture. Next up is the Boolean. The Boolean is kind of weird in a certain way because it can only have two values. It can either be true or false. And they only use one bit, the last one here. It is still using an entire byte, however, which is kind of unfortunate. There is no other way around it unless you're writing multiple booleans at a time. I wrote a function that if you group booleans as an array, they will group together. I will show you in a short bit. Next up, we have the character, which is also kind of an odd one. If you write regular characters like A, B, C, for example, they will use 1 byte because they fit into the ASCII table. If you write more special characters, for example, like this ×2, power of 2, my apologies, they will use 2 bytes because this only fits into the Unicode table. Fortunately, the application can deal with that. So if I, for example, write this and then read again, I'm going to skip the first byte because that's the length, and I read a character, I will read A, and then I will read the power of 2. So first it read only 1 byte, and then it read 2. So it can tackle this problem. But keep in mind, if you are allowing special characters in a certain way, that the length may vary. Next up is the string. I already showed you also in the previous example. A string, for example, let's write A, B, C, is using 1 extra byte, the length of the string. So the 65 is the A, 66B, and 67C in the ASCII table. And then it is prefixed by a single byte that shows how long this string is going to be. So if you know a string is always going to be 3 characters, for example, high score tables in arcades, it's always 3 characters, then maybe it's better to write 3 characters instead of a string because you're saving the extra byte. Apart from that, of course, if you have variable character names or something, a string is very useful. So if you write and read it again and then start reading a string, thanks to the extra byte, it will know exactly where to stop. So let's write A, B, C, D, E. Write again, read from the same spot, and it will know that it can read a little bit further thanks to the length. So something small to keep in mind. Next up, we have arrays. You can write every single type as an array. Let's, for example, add 10 random bytes, and that will be 10 bytes as expected. If you write 10 shorts, then that will be, my apologies, that will be 20 bytes because it's twice as big. With Booleans, however, it's a little bit different because you can group them as mentioned before. If I write 1 Boolean or 2, yeah, it will just add 1 byte because it's using the last 2 bits now. If I write 3, it will group them all together. 4, all the way up until 8. Now it's using all these bits for booleans. So you can group them, which right now, if you would want to write 8 booleans, for example, for which areas a character can go to and so on and so forth, this will save you 7 bytes. And if you spread that around, one byte per pixel, that's 7 pixels already. This can add up quite quickly, especially if you want to hide a little bit better, but we'll go through that later. So that's the only array that's special. All the other ones also have array variants, but they do exactly as you expect. They add just the amount extra that the array is long. Next up, about hiding better, we have the data bits per channel option. For now, I've used the last 2 bits of the red, green, blue, and alpha channel every time. But imagine you want to hide even less data. You can maybe only use the alpha channel, or maybe only use 1 bit for each. Every combination is possible. Let's show you if I only use, for example, the red channel to write the number, well, let's just write 10 random bytes. I'll explain this later and write it. Now you can see it super clearly what's happening. Like, this is the red channel. It's just all over the place. It's not really well hidden. But if we use 2222 and then write it, well, now it's a little bit in red, a little bit in green, a little bit in blue, and a little bit in the alpha channel, which is already way more obscured. So I would not suggest like going above 2, 3, very, very maximum, I think, bits per channel. If you need less data, for example, if you only need to write the number 10, which is kind of weird, but maybe you can just use 1 bit here. Now it will be very well hidden, but it will use 8 pixels per byte, while previously it would only use 1 pixel per byte. So that's all the options you have here. I would suggest you start off with 0002, which is what the roller coaster from previously used, and then gradually move up maybe like this, and then finally, I think this is, I wouldn't say the maximum, but this is what the PQ8 uses. You can kind of see how visible things are. That's the data bits per channel. Next up is the length prefix type. For now, you've seen so let's write the number 10, for example, and then write it, and then read it again, that there are 2 numbers here. The first one is the length. We use that because otherwise you need to load and read the entire texture if you only stored 1 byte, which is kind of silly. So that's kind of a trade-off. You are wasting 1 byte, but on the other hand, you're speeding up reading times by a lot. We can also prefix it by nothing and write it. If we read it now, you will see the 10 we have written, and then all data, because it doesn't know where to stop. It doesn't know whether the last 2 bits of every channel is still something we need or not. So if you always know that you want to stack it to the brim, like every single thing has to be used, choose none, because that saves the most amount of space. But if you want to save on loading times, you can prefix it with a length. If you know that you will always have less than 255 bytes, you can go for a 1 byte prefix. If it's bigger, you can go for a short, integer, or long. These, of course, will take up more space, but that's the trade-off. If you don't know how much data you're going to need, so like maybe it's going to be an integer, but maybe it's going to be a byte, you can go for dynamic. Dynamic will always be 1 byte, and then the exact length it needs will be behind that. So, for example, let's write the 10 again and read it. It will prefix, the first one is a type. So it says, oh, well, it was smaller than 255. Let's use a byte. And then this is the actual byte that it's using. If we would, for example, write 300, bytes, which currently doesn't fit into this texture. So let's make some more space and write it and read it again. Now it will say, hey, the first, a single byte wasn't enough, so I'm using an unsigned short right now, and then this is the short. So if I read this, this is for, my apologies. So this is 3, and then I'm going to read an unsigned short, and that's 300. So the 44 and 1 here is 300 if you combine them, and that's the exact amount of bytes I've written. So in the case that it's from a byte to a long and you don't know, dynamic is the most efficient solution, because if you always choose for a long, it will always be 64-bit. While if it may be a byte, then you're saving 32 bits here. So, but most of the time, I think one of these presets will do just fine. And the last one is a fun one. It's the data zones. You can choose where you want to have data and where you don't want data. For example, if you use a part of the texture for something else, let's say a player can make their own shield with icon, and you want to write all the dimensions and all that sort of stuff in the hidden data, but you don't want the actual icon to be obscured because you want to use that in the game directly, you can choose in which zones you want to write. For example, yeah, let's start, for example, like this. I'll make a couple of zones, 6, 6, and then 8, 8. Now we have 4 small squares where it will write horizontally to the right and downwards. So let's clear this all and write the number 1, for example. This is the most visible. I'll move it like this. And then add more. Now it's finished the first square. Now it's moving to the second square. And I'm going to speed up a little bit. So now it is only writing in those areas. Keep in mind, however, that you don't want these areas to overlap. It will not check for it, but make sure they do not overlap. If you, for example, want to write vertically, well, you can as well. So let's make a big zone where it's writing vertically to, well, to the right and downwards. If we add all this again, it will write vertically downwards. You can make it write to the left, upwards, for example. Now it's writing from the left corner here upwards. And all other combinations are possible. Maybe horizontally to the left and then down. Oh, now I added 2 zones, just like this. So now it's writing to the left and down, but maybe you wanted to write to the left and up, and so on and so forth. Every single combination is possible. And for fun, I added an option where you can write clockwise or counterclockwise if you want the center of your image to be the most intact, because that's what people are going to look most at, and then only the borders, for example, are going to be stuffed with data. Let's write something clockwise and start in the this is now this is the top left corner, for example. It will add multiple data zones. So it's basically a utility function. It doesn't do anything different than what I just did, but it calculates it for you, which is kind of cool. So if I want to write 10 random bytes and write it, it will start writing in a spiral. I will add more, it will continue the spiral, and so on and so forth. You can write clockwise, counterclockwise, use any starting corner. Yeah, that's just a fun little thing I added. And that's it. So, oh no, of course, reading is the same thing. You can read any type you want. You do need to know which type it is, of course, but I think that makes sense. If you have any more questions, you can always leave a comment here. or you can leave a post on the Unity forums, and I will hope to see you there and help you there if you need to. Have a nice day.